Hi everyone. In this video, we're going to be talking about heat capacity and specific heat. So in our last class, we started talking a little bit about heat and energy. We talked about endothermic and exothermic processes. Endothermic means that heat is being absorbed in the process, and exothermic means that heat is being released during the process. Well, today we're going to take it a step further, and we're going to talk about the fact that every chemical, every pure substance has what's called a heat capacity or a specific heat constant. The amount of heat needed to increase the temperature of an object exactly 1 degree Celsius is the heat capacity of that object. Every pure substance has a heat capacity. The heat capacity of an object depends on both its mass and its chemical composition. The greater the mass of the object, the greater its heat capacity. Which would have a greater heat capacity? A cup of water or a drop of water? Clearly a cup of water would have a greater heat capacity because of having a significantly larger mass. Heat capacity depends on both the mass of the substance and its chemical composition. Specific heat is even more specific than the definition that I just mentioned of heat capacity. I've always thought that they call it specific heat because it's honestly very, very specific. The specific heat of a substance is the amount of heat it takes to raise the temperature of a 1 gram sample by just 1 degree Celsius. See why they call it specific heat? Because it's really specific. It's specific for the mass of 1 gram and specific for the temperature change of 1 degree Celsius. So yes, it is similar to heat capacity, but heat capacity could be for any amount of mass that you want to look at. Specific heat is specific to 1 gram of a sample and 1 degree Celsius. Again, every pure substance has a specific heat constant. And if you look at your notes page, I've listed for you the specific heat values of some common substances. Like water has a specific heat value of 4.18. That's actually a really high specific heat value. It takes a lot of energy to raise the temperature of a sample of water. It takes 4.18 joules of energy to raise the temperature of 1 gram of water by just 1 degree Celsius. And you know, this is what I always think of when I think of trying to get a pot of water on the stovetop to boil when I'm making my macaroni and cheese. It takes a good while. It takes some time. That's because of water's high specific heat value. It takes a lot of energy to change the temperature of water. Something like aluminum has a much smaller specific heat value, 0.9, just 0.9 joules per gram. That means aluminum's going to heat up really quick. It doesn't take as much energy to raise the temperature of a sample of aluminum. Water has a really, really high specific heat, so it's going to take a lot of energy. There's an equation that we're going to be using to calculate specific heat values, and you're going to be doing this on that specific heat worksheet today. The equation in our notes is Q equals MC delta T. Q in this equation stands for heat or energy. Most likely that will be measured in joules, although we did see last class that there are several other units that can be used for energy. Mass, M stands for mass, the mass of the sample, most likely in grams or could possibly be in kilograms. This letter C is the specific heat constant that I was just talking about. Every pure substance has a specific heat constant, the amount of energy that it's going to take to raise the temperature of a 1 gram sample by just 1 degree Celsius. And this delta T stands for change in temperature. Specifically, that's going to be final temperature minus initial temperature. And in this case, unlike our last unit, it is not necessary to convert these temperatures. Degrees Celsius works perfectly fine. Let's look at a couple of sample problems. Number 1 says the temperature of a 95.4 gram piece of copper increases from 25 degrees Celsius to 48 when the copper absorbs 849 joules of heat. What is the specific heat of copper? So to solve a problem like number 1, I'm going to use this Q equals MC delta T equation. They've given me the mass of 95.4 grams. They've given me a temperature change. 48 is final minus the initial of 25. Q, the amount of heat absorbed, which by the way would mean this is an endothermic process, is 849 joules. What they're asking me to solve for is C, the specific heat. So I'm just going to do a little bit of plug and chug with my equation, Q equals MC delta T. For Q, I'm plugging in that 849. For M, I'm plugging in the 95.4. C is what I'm solving for. My temperature change would be 23. 48 minus the 25. To solve for C, I'm going to divide both sides of the equation by 95.4 and divide by the 23. In my calculator, I would type 849 divided by 95.4. You can hit equals there if you'd like. Then divided by 23. Yes, you press the divided by button twice on your calculator. And you should get an answer of about 0.39. And that would be labeled joules per gram degree Celsius. Let's look at number 2. Question number 2 says, how much heat does 32 grams of water absorb when it's heated from 25 to 80? Again, to solve this kind of problem, we're going to use Q equals MC delta T. In this case, we're solving for Q. 32 grams is the mass. The specific heat of water is 4.18. It's listed in the table above. And my temperature change would be 80 minus 25. To solve for Q, Q is heat, all you're doing is multiplying. and I would label my final answer with joules for heat or energy.